Everything will be recorded, and you'll get access to that file after the session. Probably by tomorrow morning I'll have it processed, and I can send you how to see the session. So as far as the material that we're going to go over, do you have some?
Yeah.
Is it stuff that you can verbalize, or is it stuff that we need to both be looking at?
Probably we'll need to be looking at it.
Okay. Do you have a camera on your smartphone?
Not a smartphone, but there's a website.
Oh, there's a website. Okay. Can you either, this GoToMeeting has a chat window in it. If you can put the website in there and hit enter, make it go into this chat window, then I can just click on it directly and it'll load.
Okay, so...
See if you can copy and paste it into that. Where it says type message here under the chat, you may need to open the chat. The chat, if it has a plus sign next to it, click on the plus sign.
Oh, okay. Got it.
Okay, and then whatever you want to send to me, put it in that box that says type message here. In other words, if I said hello and then hit enter, it goes to you like that. So,
Okay. Let me get my planner real quick.
Yeah, go to that website on your computer and then copy and paste the link into GoToMeeting, and I'll pull it up.
Yeah. One moment.
Is it My Math Lab or one of those?
Sorry about that. I had to get my planner.
It's okay.
Okay. Okay, so let me minimize this.
Okay. And if it requires a password, I can enter the password from my end, if that's the only way for us to do it.
Okay. So let me go to it really quick.
Yeah, go to it and then copy and paste the URL into GoToMeeting. Before you log in.
Yeah.
We'll want to log in on my end.
So let me long peek, Mrs. Watson. Okay, so now...
Do you know how to copy and paste that URL?
Yeah, I just can't find the chat bar.
Okay. It's towards the bottom of the GoToMeeting screen, and the chat may have a plus sign, and if it does, next to it, click on the plus sign, and that'll open it up. If it already has the minus sign next to it, then just type in that lower window where it says type your message here.
It's not there.
Okay. Can you read this URL address to me? And I'll write it down? Is it real long?
No.
Okay. What is it?
So www.bigideasmath.com/students/
bigideasmath.com
Yep.
slash students.
Slash.
Okay. Let me pull that up. In fact, yeah. Big ideas math slash
Students.
Slash. All right. Okay.
Yep, and then you're going to want to go,
What's your...
instead of, to the left, instead of Common Core 2014, just regular Common Core.
This one here?
Go down to, yeah, go back.
There's Common Core. Is this right?
Yeah, and then you want the accelerated one.
One in the middle?
Yep.
Okay. So I don't need to log in.
Nope.
Okay. Which one? Which chapter here?
Well, I'm checking right now.
Okay.
One second.
In fact, let me save this. Let me bookmark this.
So go to chapter 2. Should be.
Okay.
Page 54 through 55, which is on the little screenish type thing, and go to section 2.1.
Whoops, I went too far here.
Yep. And all the pages are right there.
We want section 2.1. Okay.
Yep.
Okay, do we have some exercises here that we're going to work with?
Go all the way down to 55.
Exercise. All the way down to 55?
Yeah. Wait, no, 54.
Okay, I think, let's see, this is 55. Which of these exercises do we want to start at?
Let me get something else this time. And it'll only take a second.
Okay.
Okay. Let's see here, 29, 30 through 42, all the even numbers in 30 through 42,
Okay.
and 55 through,
Okay.
yeah,
Why don't you
52.
hold that second group and we'll start on 30. So here, let me move
Well,
this.
we need to start on 29.
29, okay. Here, let me get both of my things up so I can, whoops. Let's do it this way. All right. 29. How are we going to rank these from in order?
What was that?
Is this right? 29?
Yeah.
Okay. You always want to think of the number line here. In other words, to figure out how to do this, let's draw a number line. The Let's label 0. What is the number the furthest to the left on the number line?
The number the furthest to the left on the number line.
Out of the five numbers that I've listed, which one goes to the furthest on the left?
Let me think for a sec. Negative 2.5.
Okay, I'm going to write that right there, minus 2.5. And what next?
Then next would be negative 1.1.
Okay. And next?
Negative 4/5.
Okay. Which is the same as negative 0.8. So we can see that it should go to the right of negative 1.1. Okay, and that's all the negative numbers. Now on the positive side, what comes next?
On the positive side, there would be 0.8.
Which is the same as 4/5. Okay, and then what else?
Then 9/5.
Okay. Now notice that I didn't label the grid on this number line. I just put where everything was.
Yeah.
And that's not, the grid really isn't important. It's knowing that negative 2.5 is smaller than negative 1.1.
Mm-hmm.
That's the real key. So once you know that, these problems become pretty easy. Ooh, that was kind of weird. Every now and then the screen goes. So how about 30? We're supposed to do all the even ones?
Yeah.
Okay, so just read 30 out loud. I won't write them down.
Okay.
Read them from left to right.
So negative 1.4, negative 8/5, or 8/5.
Okay, hold on. Let's convert negative 8/5 to a decimal.
Okay, so that would be negative 1 3/5, which would put us at negative 1 and negative 1.6, right?
Correct. So that actually goes to the far left. In other words, until you convert these to the same thing, you can't really compare them very well. So we can either convert this to fractions or convert this to decimal. And since we have decimals here, and we'll convert this to a decimal, if we convert everything to decimals, then we'll be able to line them up real easily.
Okay.
So the far left is negative 1.6 or 8/5, negative 8/5. And then afterwards, what comes next?
So negative 8/5, negative 1.4.
Okay. And then what?
Then negative 0.9.
Okay. And then what? That's
And
all.
then
That's all the negative numbers. How about the positive numbers?
1/4.
Because that's the decimal what?
0.25.
Okay. So 0.25 and then 0.6. Okay. So the trick on these is just to make sure that if one's in decimal and one's in fraction, that you, in order to compare where they're at on the number line, we kind of need to have them in the same thing.
Yeah.
Okay. About 32. Should we just do the evens, right?
Yep.
Okay.
1 sec. Let me write all that down really quick.
Okay.
That's better. Okay.
I really want to label this the 0. So how are we going to compare minus 7/2 with minus 2.8?
1 second. Okay, so 7/2. I know you just divide 7 by 2, which amount to, let me think, 3.5.
Okay. So what goes furthest to the left?
Okay, so that means negative 7/2.
Okay. What next?
Okay, 1 sec. I need to write this down really quick.
Okay.
And then next would be negative 2.8.
Okay. And what decimal is minus 5/4?
Minus 5/4 would be negative 1.25.
Okay. So that comes next. And then on the positive side, how do you compare 4/3 with 1.3?
What was that? I didn't catch it.
We've done the 3 negative numbers. Now the only thing left is where we put 4/3 and where we put 1.3.
Okay, so 4/3 is 1 3/3, and that makes 1.33 repeating. And even though repeating, I make it the same thing as more than 1.3.
So 1.3 comes next, and then 4/3 comes after that.
Yep.
Just barely, because this is 1.3, and there's a 0 implied there, and here it would be 1.33 repeating. So that's a little bit more like you said. Okay? And the coin, you said all evens from 30 to 50 something?
30 to 42.
Okay, so 34. Let's look at 34. You lose 1/4, 2 dimes, and 2 nickels. Write the amount as a decimal.
What did he say? This computer's not...
I tell you what, you've got your, oh no, you don't have your camera turned on. Let me turn my camera off, because that's what happens. The audio kind of gets bad if the camera is on. That should help.
Sounds like a wet computer trying to talk.
Oh, yeah. Okay, so you lose, why does it say you lose? 1/4.
It wants us to do negatives.
Oh, 2 dimes and 2 nickels.
Yeah.
Okay. Write the amount as a decimal.
Okay, so C. Negative 25.25. Negative 0.25 plus negative 0.2 plus negative 0.1 would all amount to did that wrong? And I have my own piece of notebook paper here.
Okay. Now let me ask you, are you using a calculator or are you doing these manually, this arithmetic?
Manually.
Good.
Manually.
I think that's a good thing to practice. Does your teacher care? Does she ask you to not use calculator, or do you have to take tests where you aren't able to use the calculator?
We usually have tests, and she doesn't really prefer
Okay.
we do things with the
Okay.
calculator.
So what's this total?
The total would be negative 0.55.
Okay. All right, and then write the amount as a fraction in simplest form. So how do I convert positive or negative? The negative is just going to carry forward, but how do I convert 0.55 back into a fraction and simplify it?
So you do 0.55 over 100.
Actually, we do 55 over 100. That's the same thing.
Yeah, it's what I meant.
Right, and then we can simplify that. What's that simplify to?
By 5, you divide both by 5, and you get 11 over 20.
Correct. And then it's negative. So that's how we convert decimals to fractions. It's pretty much put the 100 under there, or the tenths if it's in tenths, and then just simplify. Okay. So 36 next.
Okay, one sec. Need to write that down. Sorry, it might be a little bit slow.
It's okay. Now also remember that you're going to get a copy of this file. I'm recording this.
Oh.
Problem is you won't get it until tomorrow, because with you and your sister, and then I have another one right after you, it's going to take my computer a while to process it. So it'll be tomorrow before you'll get a chance to review it.
Okay, yeah. So it's due tomorrow though, which is
Okay.
problem.
Well, then it's probably better if you go ahead and keep writing. Although I do have my doubts as to whether that's the best way to learn. My students do a variety of things that works for each one of them best. Sometimes they'll take notes. Sometimes they'll write the same stuff I'm writing on my drawing tablet. Or in your case, you're writing what the answers are to these questions, I imagine.
Well, yeah, I have to show my work too.
Okay.
With you.
Okay, good. As long as you can recreate it, that's all that really matters.
Yeah,
So,
and I make sure I'm able to follow along.
good.
So I know that if a test comes along, that I would be able to do it.
That's the key, is that it's not so much that I'm helping you do your homework as much as you're learning this material, and you could now do it on your own on a test.
Yeah.
So 36, how do negative 2.2 and negative 2.42 compare? Are they, where's the less than and equals? Got three choices. It can be less than, greater than, or equal.
Okay, so negative 2.2 would be greater than negative 4.2.
Okay, then negative 2.42, correct.
Yeah,
Okay.
because
How about 38?
okay, 38 would be the same
Okay.
because 1 7/8. If you turn it into what do you call them again?
This is a proper fraction, and this is an improper fraction.
Yeah, an improper fraction. It would come out as 15 over 8.
Okay. About 30, or 40 rather.
So 40.
Uh-huh.
That would be, okay, I'm not good with,
All right, so let's figure out how to convert 3/11ths to a decimal.
11 as a decimal would be 0.9999.
Well, let's do it the hard way. Let's do this long division. Okay, how do we do this? How do we figure out what 3/11ths is? We're going to divide 11 into 3. Doesn't go, so there's a 0. Decimal point's in the same spot. Now what? 11 into 30 goes how many times?
It goes 2 times.
Okay, now we multiply the 2 times the 11. Subtract. Bring down the 0. Divide it again. How many times does 11 go into 80?
11 goes into 80 7 times.
Okay. Multiply. Subtract. And so we now know that it's repeating because it's going to go 2, 7, 2, 7, 2, 7. So now, which of these is bigger or smaller?
Okay, so that makes... Okay, so
now we
wait,
have,
and you
so we have minus 5.2727.
Yeah.
And on the other side, we have minus 5.222. So which is those bigger?
The bigger one is negative 5.222 repeated.
So the direction goes in that way. In other words, this is bigger than this.
Yeah.
Okay.
There's more of the one on the right.
Right. It's all about where it is on the number line. If there's the number line, this thing's over here at minus 5.27, and this thing's right there at minus 5.22.
Yeah. Because of absolute value. Yay.
Okay, 42. Find one terminating decimal and one repeating decimal between negative a half and negative a third.
Okay. Well, I know that negative 1/2 equals, one sec, let me make room for this. Okay, so 42. Negative 1/2 is equivalent to negative 0.5.
Okay.
And negative 1. Oh, you okay?
Uh-huh.
Okay. Equivalent to negative 0.33 repeated.
Okay.
Let me close that window.
Okay. Now you realize that you're seeing my screen.
Yeah.
So you shouldn't have a window. When
Yeah,
you said close that window, which window were you referring to?
I was talking about the window. There was noises coming out of it, like
okay.
there were trucks and stuff.
Okay. So if we look at the number line, and here's 0, let's call this minus 0.5, and we'll call this minus 0.333. So they want a number between there. Give me a number between there that would be a terminating decimal.
0.4.
Okay, good. That's what I was thinking of. Negative 0.4. And how about something that would be a repeating decimal?
0.4 repeated.
No, what they mean as a repeating decimal is like 1/3 repeats, because the last digit repeats. We can never write down the last digit. 0.4 is terminal, because if we wrote down all the rest of the digits, they would all be 0, which means I am being perfectly accurate by just writing it as 0.4. That's
what I meant to say was actually 0.4 repeating.
0.444.
Yeah.
Good. Okay. And that's equal to some fraction. We're not sure what that fraction is, but they don't want it anyway. So let's look at 44.
45.
40.
It was 45. It was 32 through 42.
Oh, okay. So, and then 45. All right.
Yeah.
Is the half pipe deeper than the skating pool? Explain.
Okay. I said that the half pipe, it is deeper than the skating pool because, no, it's not deeper than the skating pool because 10 feet is greater than -5/6 feet.
So which one's the deepest? Skating pool or the half pipe?
The skating pool.
Right. It's 10 feet deep. That's deeper than 9 5/6 feet.
Yeah.
The fact that there's a negative sign on there doesn't really change the concept. We know that that's 10 feet deep. It's measured as a -10 because when you're measuring something on the vertical or horizontal, you tend to treat downwards as negatives and to the left as negative.
Okay.
Okay. Okay. And then are we going to do every odd or every even on these also? What's next?
Here, 1 second. Let me write that down. 45.
And you can view that one as a number line problem also. If I put that on the number line, there's -10, there's -9 5/6. Well, when they say which is deeper, they really are asking about the absolute value of that number. And so 10 would be bigger than 9 5/6, which makes it deeper. Okay. What's the next problem we need to do?
46.
Okay.
Okay, the table shows the changes from average water level of a pond over several weeks. Order the numbers from least to greatest.
Okay. Same exact problem as what we were doing, only it's structured as a word problem.
Yep. Okay, so
what's our strategy going to be? We got 2 of them that are in decimal, 2 of them that are in fractions. What's the easiest way to compare numbers? Decimal or fractions?
I think that decimals are.
Definitely. In other words, it's hard to compare certain fractions with one another. But if everything's in decimal, then it's easy. So what is -7/5 in decimal?
Okay, so -7/5 is equal to 1 2/5, which is equal to 1.4.
Okay. And how about the next number?
Okay, so we would have to divide 11 by 5.00.
Actually, it's 11 into 5.00. In other words, this is dividing 5 by 11.
Yeah, that's what I meant.
Okay, so what's this equal to?
Okay, so
Now, we're going to ignore the 1 for the moment. We're not going to forget about it. But
yeah,
at the present, the only thing we really want to do is convert the 5 over 11. Whatever decimal that's equal to, then we'll be able to see what the whole decimal is equal to. So what's the first number here?
okay, 0.4.
Okay.
And then when you subtract 50 to 44, you get 6, and then you bring down the 0 and get 60, and then you get 5, and then 55, and then you subtract that, and you get...
The moment you get back to 50, you know you have a repeating decimal.
Yeah.
Because it's just going to go the same every time. In other words, when we divide 11 into 50, we get 4, 5, and then we're going to get 4, 5 again, and if we keep going, we'll get 4, 5 again. So this number can be written as negative 1.45 repeating.
So
Okay, and then we have the next number is minus 1.45 non-repeating. And then the last number is minus 1 what? How do I convert 91 over 200?
One moment. Okay, so 91 over 200, you divide, you put the 91 in the box. Forget, 200 divided by 91.
No, 91 divided by 200.
Oh.
In other words, the denominator always gets read last.
Okay.
We don't really talk about this, and we don't really say it's 200 dividing into 91. It's 91 divided by 200.
Okay.
Okay? And what is this equal to?
And then, so that would be equal to 4.
What's the first digit?
4.
Okay.
Wait, no, 0, and then another 0.
0.4.
Yeah,
Okay.
and then 4.
Okay. 200 goes into 1100 how many times?
And 1 second. Yeah, so 100 goes into 200. Sorry.
So 5 times. And then 5 times 200 is 1,000. And I subtract it. And so 200 goes into 1,000 exactly 5 times. And now there's no remainder. So I can essentially put zeros after that if I want. It's not a repeating decimal.
So 0.455.
So we bring forth the 1, so it's minus 1.45500 if you like. Now let's rank these numbers. What's the far left number going to be?
Okay, so the number that would be the farthest left would be minus 0.45.
We're looking for the biggest.
0.45 repeating.
No,
Would be,
because this would actually be 454545. This one down here is 1.455. So this is a greater, I don't know how you want to call it, a larger negative number than this is. It belongs to the left on the, let's draw a number line. Here's 0. So the far left is going to be minus 1.4550. What's next?
and then next would be 1.45.
1.45 repeating.
Yeah.
Okay. Okay, and what's next?
Then next would be negative 1.45.
All right. And finally,
Then it would be negative 1.4.
yeah, because I can add a 0 to that. It kind of depends. This adding a 0 is helpful because it tells you that there's really no more information. In other words, knowing that this is 0 is I know that's not a repeating decimal now. But this repeating decimal up here, I can always add 454545. So, okay. That one was 46. What's next?
One moment really quick.
Okay.
Need to arrange the original numbers into order.
Uh-huh.
Comma.
That's a good question, actually, because they're so close. They're all very, very close.
Mm-hmm. I learned something new today. That's good.
Ah, critical thinking problem. Do you have to do those?
Yeah.
Okay.
47. Okay, so a and b are integers. One is negative 1 over a positive. So that would mean when a is negative.
Okay. So when a is less than 0, because it
Yeah.
can't be 0. Notice that the first commandment of mathematics is never ever divide by 0.
Yeah, because that would mean it's undefined.
Yeah. Now, when they say a and b are integers, 0 is actually an integer. So they should have covered themselves here and said they're integers that are non-zero. They should have said given a and b are non-zero integers. They kind of left themselves open by not putting that in there. But nonetheless, whenever a is negative, this quantity would be positive because you would have a negative divided by a negative. Here's something, just in case you don't know this. These are all the same.
Yep.
Okay, so when is 1 over a times b positive?
Okay, so 1 over a times b is positive when a and b share the same sign.
Good. Okay, what's next?
A moment, let me write that down.
That's good. Either when they're both positive or they're both negative. But the most efficient way to state that is when they share the same sign.
Okay, so 48, I think. Yep, 48.
Okay. Adding and subtracting fractions is far more difficult than multiplying fractions.
Yeah, because
notice how easy this would be to multiply.
Denominator.
Right. We don't ever have to do that if we're multiplying or dividing. So it's worth noting that this would be an easier problem, and in fact, that would be an easier problem.
Yeah.
Real easy to multiply and divide. But when we're subtracting or adding, we need a common denominator. What's the common denominator going to be here?
The common denominator would be 35.
Okay. And so what's the top left here?
So the top left would be, let me think, so 21 over 35.
Okay. And what's the second term in the numerator going to be?
10 over 35.
Okay, now we can operate on the numerator. And that's fully reduced because I know 31 has no factors other than 31. It's prime.
Well, it does have one, but...
Well, it's prime, though. Have you talked about prime numbers at all?
Yeah.
Okay. So prime number is any number that can only be divided by 1 and itself, which is 31. Can be divided by 31, but that makes it prime. And
the only exception of it being even is number 2.
Right, right. Prime numbers are very, very interesting. If you ever get a chance to see on the Discovery Channel, there's a program called Cosmic Breaking the Code. And it's all about prime numbers and how much effort mathematicians have spent for the last 2,000 years trying to figure out the mysteries of prime numbers. Some of them think that that's the secret of physics and the whole universe is in prime numbers. So there's a lot more there than meets the eye when you're talking about prime numbers. Okay, so how about 49? You have to do that one?
Yep. Until 52, and then we have to do more pages. Yay.
Okay.
Okay, so anyways.
What's the common denominator here?
Common denominator would be 30.
Okay. This term is what?
One moment. That would make 27 over 30.
Right. And the way I don't know how you look at this, but the way I convert 9/10 to 27/30 is I multiply the top and the bottom by 3. In other words, I can take a fraction and multiply it by 1 all day long without changing its value. So as long as what I multiply is 1, which is 3 over 3, I turn its denominator into my common denominator, and its numerator becomes 27. Now, to convert 2/3, I got to multiply that by 10 over 10.
Okay, cool.
And that makes the numerator 20.
Okay, so, yeah. Sweet. And that comes out as 7/30.
Which, again, is reduced because 7 is prime.
7 is prime.
And it doesn't divide into 30. It's not just that it's prime. It's got to be, in other words, if it was 7 over 35, that does reduce. Even though 7 is prime, that still reduces to 1/5.
Yeah, because...
So you have to check as to whether that prime number divides into the other number.
Yeah, because the numerator and denominator have to share at least one factor.
Right.
Besides 1
For it to be reducible. Yes.
Yes.
Okay, how about 8.79? These are much easier to do decimal.
Yeah.
Don't have to do a common denominator. What's this equal to?
Okay, let me do the math. $4.72.
Okay. You're pretty good at your arithmetic, but if you wanted to improve one single thing that would make math so much easier for you over the next 4 years, it's to really get good at arithmetic. It's being able to do problems like this quickly.
Yeah.
Okay, and not be dependent on that calculator. It's hard to do in your generation because when you've had a calculator since you've been born, it's hard not to rely on calculators, so you tend to lose your arithmetic ability. Or not you, but most people do. If they, you go to the average adult and they probably can't do this subtraction because they've been using a calculator for the last 30 years and they forgot how to do it manually.
Yeah.
And you don't want to do that. You don't want to have that happen. And in fact, it's worth going to websites that let you practice your arithmetic, just practicing and drilling and getting really good would really come in handy for you. Anybody, not just you. You're fine at your arithmetic. There's nothing wrong with your arithmetic ability at all, but it can always be better. I'm lucky because when I was a kid, you know what we did in math class all day?
Arithmetic?
We went to the board between the grades 2 through 6. All math class was standing at the board solving problems that the teacher would yell out, and it was always 2 people, and the person that could solve it first got to stay at the board. And so it was like a little competition. And so I got really good at my arithmetic, and I wanted to stay at that board a lot. But that's all we did, and I think things have changed a lot now because, the calculator means that you don't have to be perfect at arithmetic, but it's still really good to be really good at it.
Yeah.
So we're going to add these. The key is to keep your decimal point below one another.
Mm-hmm.
As long as you do that, everything will line up right. So what's this equal to? Adding?
What's that? 21.15.
Good. Okay, and then 52 is the last one?
Yep.
In 1 year, a company has a profit of negative $2 million.
Wow. I
In
didn't
the
know.
next year,
How do I
the
turn
company
their
has a
audio
profit of
off?
$7 million. How much more money did the company make the second year?
I don't know. I don't know.
That was weird. I never had the audio come on. I didn't know they had audio. Okay.
Oh, you click on it and it.
Oh, and it starts, okay, I must have accidentally clicked on it, yeah. Oh, so the company has a profit of minus $2 million. Means they lost $2 million. And in the next year, they had a profit of $7 million. How much more money did the company make the second year over the first?
Okay, so if you take the absolute value of both of them and add it together, you get 9. So 9 million.
Okay, that's correct. Let me show you a different way to look at it. Here's minus 2. There's plus 7. I want the distance between those two numbers. Whenever you're taking the distance between a negative number and a positive number, then you could just say, well, it's 2 from there to 0, and it's 7 from there to 7, so that's 9.
Yeah.
Now,
So like
if I had a negative number, let's change the problem a little bit. Let's say in the second year they lost 1 million. Now, how much better did they do in the second year over the first year?
they did $1 million better.
Yeah. And your absolute value thing might not work real well if they're both negative like that. I guess it would still, if I took the absolute value of that and the absolute value of that and subtract them. Of course, before you took the absolute value of both and added them. So it kind of matters whether they're both negative or if one is negative and one is positive or whatever. But let me do something else with you. Tell me the answer to this.
Okay, so negative 7 minus 9 is negative 16.
Good. Believe it or not, that will give a lot of people a lot of trouble. And the reason why is because these dashes mean something different. These dashes don't mean the same thing. This dash is a negative sign.
Yeah.
This dash means subtraction. Okay? So the way I teach people to do this is I say turn all subtraction problems into addition problems. And the way you do that is you change the subtraction sign to a plus and you change the sign on the number that was being subtracted. So now we have minus 7 plus a minus 9. Now nobody misses that. Everybody knows that that'll come to be negative 16.
Yeah.
So just a little trick when you're subtracting negative numbers or positive numbers. Turn them always into addition problems. In the same way that we always turn this into a multiplication problem. Right? How do we do that? How do we do 2/5 divided by 1/7?
You switch the last factor.
I flip that and multiply. And now I just go straight across. Multiply both numerators, multiply both denominators. So in the same way that I change almost all division, at least whenever I divide by a fraction, I always do that. I always change it to a multiplication problem. Well, I do the same thing with subtraction. I change all subtraction problems to addition problems. Okay. So does that cover all the material, or you said there were more pages? We only have a few minutes. In fact, I have a 5:30 session, so maybe we better wrap it up at question 52. Well, this is good. I'm glad your material's online. That'll make it a lot easier for us. Your sister still is dealing out of a textbook, and that's going to be somewhat problematic. She said her cell phone or her camera doesn't work real well on her cell phone, so she may need to borrow your camera to take pictures of her textbook material and send that to me in advance. But you're fine, because we can always go to here. Okay? David, give me your email address, and I will send you the link as to where the recording of this session will be.